Okay, the second one here has a fancy root. That's what we call a double root. Okay, the roots are identified the same way. You're just looking at each of these three different sets of parentheses to identify there's three different points of intersection on the x-axis. One of them is at x equals 2, x equals -2, and x equals 6. And I've suggested to make some sort of notation so you don't lose the fact that that is a special root. It's a double root. We're still going to identify the roots on the x-axis, 1, 2, and that's at -2. 1, 2, there's another root, 3, 4, 5, and 6. Now that's a little far, but that's okay. There's a dot there. But this, I would suggest making a little asterisk or something to signify that at 2 there's something different happening, so that we can make sure that we don't forget that there's a 6 and there's a 2. Again, the end behavior is a positive 1, so we're increasing as we go through, and since that's not anything special, it's a normal root, we're going to be going up again. That's positive, this is up, and we'll see on the next one that's different. As we come back around, we're making note of the fact that there's an asterisk there, and so we're going to, instead of going through it, we're going to bounce off of it like this. It's going to come back down, and it's going to look similar to the other graph, and I want to point out the similarities. Okay, they both kind of look like W's, but you've got 4 points of intersection there, only 3 points of intersection here because one of those is a double root. Okay, it's still a 4th degree polynomial because it has x squared, x third, x to the 4th power, but it only has 3 intercepts because one of them is a double. Oh, how rudely interrupted.